Microprocessor and other integrated circuits are made, or fab, starting from a chunk of silicon and resulting in a device with millions and millions of transistors that now run almost everything in your life. Microprocessor is made mostly of an element called silicon. Silicon is rather common in Earth's crust and is a semiconductor. This means that depending on what materials you add to it, it can conduct when a voltage is applied to it.
This concept of converting desert sand to silicon dioxide, which is commonly known as silica, are used by electronic companies to build an efficient processor nowadays. But before, pure silicon can be successful when it undergoes several stages to be finer than it seems. First, silicon dioxide must desegregate oxygen into its compound element, which are silicon and carbon by means of heating in the arc furnace that ranges into 2000 degrees Celsius. When the oxygen and carbon reacted in molten silica, it will produce carbon dioxide and silicon. After the process takes place, the end result of it will come up a substance which is referred to as metallurgical grade silicon that is 99% pure. Creating cylindrical crystal, pure silicon must be turned into single crystal that have a regular atomic structure. This transformation is achieved through Shokransky process. Electronic grade silicon is melted in rotating quartz crucible and held at just above its melting point of 1414 degrees Celsius. After the process done, the result of it produces gold that comprises single silicon crystal that measures 300 mm in diameter.
Integrated circuits are approximately linear, which is to say that they are formed on the surface of the silicon. To maximize the surface of area of the silicon available for making chips, the bowl is sliced up into these called wafers. The wafers are just thick enough to allow them to handle safely during semiconductor fabrication. 300 mm wafers are typically 0.775 mm thick. In electrical properties of paper will be modified to exposure to ion beams, hot gases, and chemicals. But this needs to be done selectively to specific areas of paper in order to build up the circuit of the processor.
The fundamental building block of a processor is type of transistor called a MOSFET. A type of device is a P-channel MOSFET, so-called because it uses P-type material. Processors also use N-channel MOSFETs which use N-type material. To make this region possible in functioning well, gates will also be included the process called chemical vapor decomposition. It's relatively connected in a copper trap by means of resultant metallic pins that throw through the insulating layer called bias. Job is therefore to find out which dies, typical name of chips, are working, a task that is carried out by wafer probe. This piece of hardware uses pins that line up with the contacts on a die, through which electrical signals can be passed to put the processor through its paces. After all the dies have been tested, the wafer is sewn up into individual dies that are sorted and deployed according to the results of the wafer test.
Final step, therefore, is to encase the bird chip into a package that most people would think of as a processor. Several methods are available for this process. Whichever one is used, the end result is that the die is firmly attached to the package, and electrical connections are made between the contacts on the die and the contacts on the package. A final test on the finished assembly is all that's needed before the processor can be shipped to a manufacturer and ultimately used to power a computer.